Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss how to improve the performance of machine learning with algorithm tuning. Algorithm tuning is a final step in the process of applied machine learning before finalizing your model. It is sometimes also known as hyperparameter optimization, where the algorithm parameters are referred to as hyperparameters, whereas the coefficients found by the machine learning algorithm itself are referred to as a parameters. In scikitlearn, there are two methods in which we can do the algorithm parameter tuning. One, grid search parameter tuning, and second, random search parameter tuning. In case of grid search parameter tuning, so it is an approach to a parameter tuning that will methodologically build and evaluate a model for each combination of algorithm parameters specified in a grid. One can perform a grid search using the grid search CV class. Now, how we can do this? Let's see in Python. Import numpy. From pandas, import read underscore CSV. From sklearn linear underscore model, import reach. We are going to optimize the parameters of the reach regression. From sklearn dot model underscore selection, import grid search CSV. Now we specify the file name. Basically, we specify the path where our data file is located. Here, we are going to work on the PIMA Indian diabetes. This dataset is very easily available on the Kaggle website. Names we specify of that of the all the variables. Data frame is equal to read underscore CSV file name. File name is the path which we have specified. Names is the names of the variable. I'll request all my viewers to kindly refer my previous videos to understand the flow of the entire lecture series. Array is equal to data frame dot values. So now we will segregate the independent variables and the dependent variable. So x is equal to array, that is square bracket colon 0 is to 8. Y is equal to array colon 8, that is the target variable. Now we'll specify the alphas, and we have to optimize alpha here. So alpha is equal to numpy dot array 1, 0 0.1, 0 0.01, 0 0.001, 0 0.0010. So we want to do the optimization for this values of alpha. Parameter underscore grid, so it is dict round bracket alpha is equal to alphas. Model is equal to reach. So we want to maximize or we want to optimize the reach regression and its value of alpha. So grid is equal to grid search CSV. Estimator is equal to model, comma, parameter underscore grid is equal to parameter grid. In this example, we are evaluating the different alpha values for the reach regression algorithm on the standard diabetes dataset. This is a one-dimensional grid search. Grid.fit x and y, that is an independent variable and the target variable. Print grid.best underscore score underscore. Print grid.best underscore estimator underscore dot alpha. So when the alpha value is 1, we get the best score. So this is known as grid search for algorithm tuning. Next comes is a random search tuning parameter. It is an approach to a parameter tuning that will sample algorithm parameters from the random distribution for the fixed number of iterations. A model is constructed and evaluated for each combination of parameters chosen. One can perform a random search for algorithm parameters using the random search CV class. In the example which we are going to discuss, this example, we are going to evaluate the different random alpha values between 0 and 1 for the reach regression algorithm on the standard diabetes dataset. A total of 100 iterations will be carried out, and it will be carried out and it will be performed with the uniformly random alpha values selected in the range between 0 and 1. So here, instead of giving a discrete values, we are giving the distribution. So how we can do this? Import numpy. From pandas, import read underscore CSV. From scipy.stats, import uniform. From sklearn.linear underscore model, import reach. From sklearn.model underscore selection, import random search CV. We have to specify the file name, or rather, we have to specify the path where our file is located. We are performing this on the PIMA Indian Diabetes, which you can download from Kaggle website. Names is the names of the variable. Data frame is equal to read underscore CSV. File name is a path. Names is the names of the variable. Array is equal to data frame dot values. So data frame dot values. Now we will segregate the dependent variable and independent variable. Then we'll specify param.greet is equal to alpha and which distribution is to be followed. That is a uniform distribution. Model is equal to reach. Now I want to search randomly from the uniform distribution the value of alpha where our algorithm optimizes. So R search is equal to random search CV. Estimator is equal to model. So model is this reach model. Param underscore distribution is a param grid. So we are taking as a uniform distribution. Number of iterations which are to be carried out are 100. Random state, it's a seed. Basically, by specifying the seed, we are in the position to reproduce the result. rsearch.fit x and y, print rsearch.best score, print rsearch.best estimator dot alpha. So almost your value of alpha is nearer to 1. So the algorithm optimizes, that is a reach regression optimizes when the value of the alpha is 1. For more videos on machine learning using Python, kindly subscribe to my channel. You can see my playlist in which I have already uploaded many videos of machine learning using Python. All these codes are very readily available in the book written by Jason Brownlee. The title of the book is Machine Learning Mastery with Python. Please don't forget to press the like button. You can also follow me on LinkedIn and Twitter.